Okay, today we're going to derive two equations that describe the position of a particle knowing its initial velocity. So we're going to know the initial velocity, we're going to know the time, and we're going to know the acceleration. But we do not know VF. And we want to describe its position. So we want to relate those four variables into one equation. And we're going to start with the definition of the average velocity and average acceleration. So to do that, the average velocity, remember, under uniform acceleration, is the sum of the velocities over 2, equaling distance over time. The acceleration equation is the change in velocity, so VF minus VI over t. So I'm going to take the strategy of I want to get rid of the final velocities in each one. So let me circle those because those are the two we want to get rid of. We want to eliminate VF. So I want to solve for that variable in one equation and substitute into the other. Or I can solve both for VF and then set them equal to each other, which is what I'm going to do. So I'm going to use my algebra to isolate VF. Everything on the top really is in parentheses and divided by 2. So I'm going to move the 2 over first. So I'm going to multiply by 2. And what I do to one side, I have to do to the other. So I end up with VF plus VI equaling 2D over t. I want to get the VF by itself, so I'm going to now subtract the VI to the other side. And what I do to one side, I have to do to the other. So I've got now VF is equal to 2D over t minus VI. So I'm going to hold on to that equation. I've isolated VF by itself. Now let's do the same over here for the acceleration. Again, everything on the top is divided by the t on the bottom, so I'm going to multiply through by t, and what I do to one side I have to do to the other. So now I've got AT is equal to VF minus VI. I'm now going to add the VI to the other side to isolate the VF. So now I've got AT plus VI is equal to the final velocity. So now these two equations describing the same event both have a final velocity in terms of different variables. We're going to set those equal to each other. So we're going to take the 2D over t minus the VI, and that's going to equal to the AT plus the VI because they're both equal to the final velocity. Now I want to solve for my distance. I'm going to do opposite operations, so I'm going to take and add the VI to both sides. Add VI. Be careful because a common mistake here is that they cancel. They don't cancel, they're adding together, and they're not squared. So you end up now with 2D over t is equal to AT plus 2VI. Continuing to solve, I'm going to multiply through by the reciprocal of 2 over t, which is t over 2. And what I do to one side, I have to do everything on the other side. So I've got t over 2 on this side. Here, the 2 and the t cancel out, so I end up with d equaling, and now let's distribute the t over 2. So I end up with a t times t, which is t squared, divided by 2, plus the 2's cancel out here, and I'm left with VI t. So the form that you'll usually see this in a textbook is d is equal to v initial times time plus 1/2 a t squared. And that is the equation that we want to hold on to, and now we can use to solve various problems. Now let's take a look at deriving another equation, except this time we're going to look at eliminating time from our equation. So time is unknown, and we want to get everything out of the denominator to create a nice equation. So we're still, again, relating A, D, except now we're going to have V initial and V final, and we do not want time. We're going to start with the same equations. So VF plus VI over 2 is equal to d over t. and A is equal to Vf minus Vi over T. So here we want to eliminate T. One thing that I found kind of easy to do is that if I take in the reciprocal or flip over, what I do to one side I have to do to the other. That puts my T in the numerator and might make it a little bit easier. So I'm going to flip everything, so I end up with 2 divided by Vf plus Vi is equal to T over D. Now I can just solve for T by multiplying through by D. And what I do to one side I have to do to everything on the other side. So I end up with 2D all divided by Vf plus Vi is equal to T. So now I can hold on to that to eliminate the T. Over here I'm going to also substitute and solve for T. So I'm going to cross multiply. In this one hopefully everybody sees that that's just T is equal to Vf minus Vi over A. And that's my other equation. I can now set again the two T's equal to each other, just as we did in the last one, and now solve to get rid of all the things in the denominator. So we've got 2D divided by Vf plus Vi is equal to Vf minus the initial velocity over the acceleration. Here we want to get rid of everything in the denominator and simplify, so we can sort of cross multiply. We're going to multiply the A up, and we're going to multiply that up. So we end up with 2AD is equal to, now we have to move this all as one variable. So it's Vf plus Vi all times the final minus the initial. We can now use FOIL, first, outer, inner, last, or the box method, to solve this system of equations. So we're going to do the firsts, which are those two, so we end up with Vf squared. Outers is now taking the outer, so we have a positive and a negative, so we have a minus Vf Vi. The inner is the next one, so that's a plus Vi Vf. And the lasts is a negative Vi squared. Notice that the two inside terms cancel out. Those are gone because they're the same value. And we're left with 2AD is equal to Vf squared minus Vi squared. So I need you to be able to derive both of these equations in under 5 minutes. That's your goal to practice. But understand the algebra in all the steps. When we're done, we will now have 4 equations to describe any motion. And those 4 equations that I want you to work on trying to really understand by definition, not just formula, is that the average velocity is equal to distance over time, total distance over total time, which is also equal to, under uniform acceleration, Vf plus Vi over 2. This is only with uniform acceleration. The second equation, we have acceleration is equal to the final velocity minus the initial velocity over time. The third one is the first one that we derived, which is d is equal to v initial times time plus 1/2 at squared. And the last one is 2ad is equal to vf squared minus vi squared. Those are the 4 equations that I want you to really be comfortable with and be able to recall at any time. So practice those derivations. Make sure you can get them down. Know these terms by definition. So acceleration is a change in velocity per time. Velocity is a change in displacement over time. And then be able to derive these. Notice that here when the acceleration is 0, you end up with d is equal to tv, which is the same as this equation up here. That's all for now, so keep practicing, and we'll see you in class.